Okay, now there's another problem. Let me see. Okay. Okay. Okay, the other problem is also, again, show that. Yeah, I hope I'm not making a mistake. Yeah, but let's see. Show that the coefficient. So we're looking at the coefficient of x to the power r in the following equation. Okay, let me write down the equation. 1 plus x squared to the power p times 1 plus x to the power q. Okay, let's say p, q are positive integers. Is equal to I have another term, so let me use this one. Summation of I is equal to 0 up to r over 2. We take the floor. P choose I multiply with P plus Q minus I choose R minus 2I. Okay. So we want to show something like this. So how can we show? Okay. So this time convolution doesn't work. Okay, they are not in the same form. They are not in the same form. It's not like this looks like a certain function. This, yeah, maybe you can still use convolution, but there's a better way. Okay. So this looks like what? This looks like we are asking about finding coefficient of a certain polynomial, right? But on the other hand, we have learned what? We have learned generating function and counting problems. They are related to each other. So what is 1 plus x squared counting? And then what is 1 plus x counting? And can you think of a certain combinatorial counting problem that has a generating function of this form? So I know 1 plus x to the power n. What is it? It means that I have n different types of things. I can choose or not choose, right? So here, 1 plus x to the power q, I know. So this, you can think of this as there are q things, q different types of things. Either I can choose 1 or I can choose 0. Is that okay? Is that okay? Okay. And then how about this one? This one. What is 1 plus x squared? So 1 plus x to the power q, let me write down. 1 plus x to the power q, it corresponds to what? Corresponds to, I have, there are q types of things that I can, maybe this is an apple, or maybe this is an orange, Maybe this is a pair. Okay, I can choose 0 or 1, 0 or 1, 0 or 1. Is that okay? So there are Q types of things. So let's say the last one is a star. I can choose 0 or 1. Is that okay? And how about this? How about 1 plus x squared? What does that mean? So 1 plus x squared. So if you think of this as similar, there should be some p types of things, right? So maybe this, that I can choose what? I can choose 0, 1, or 2. Is that okay? 0, 1, or 2. So what kind of things I can choose? Maybe this is a, I don't know, maybe this is shoes. So this is shoes. I can choose 0. I can buy no shoes. Somehow, for some strange reason, I can buy exactly 1. Or I can buy a pair together. Is that okay? So maybe this is chopsticks. So for some reason, I'm not buying anything, or I may buy just one piece of chopstick, or I may buy a pair of chopsticks, okay? Or maybe this is glasses. Somehow I may buy 0, or I may just use half of it, or I may take a pair of glasses. Is that okay? Or 1 or 2. Okay, and then what else? I don't know, the strange things. Yeah, but maybe, yeah, what kind of things? Maybe some, okay, so let's say there's some wedding dolls that I can buy 0 or 1 or 2, okay? Okay, maybe you are just, you just know the bride, you don't know the bridegroom, so you just want to give some, okay, that's strange, okay, but whatever. So you can buy 0, 1, or 2. Now, so this will correspond to a generating function of 1 plus x squared to the power p. Am I correct? And then now, the question here, this is the key question, to link this whole thing with the above problem. What is the meaning of the coefficient of x to the power r? What is the meaning? What is the meaning of the coefficient of x to the power r? It is the number of ways that I can choose exactly r objects. Okay. Maybe I'm picking 2, so maybe let's say r is equal to 4. Maybe I'm picking 2 shoes, 1 chopstick, 1 orange. Is that okay? Or maybe I'm picking 2 shoes and then these 2 dolls. Or maybe I'm picking apple, orange, pear, and star. Okay. How many ways can we choose exactly r objects in total? So, okay. And then we want to show that, okay, the value, the number of ways is equal to this summation thing. Okay, let's take a look of what is meant by the summation thing. So let's take a look. So we have p choose I here. So logically, out of these p items, I want to choose I of them. Why do I want to choose I of them? Look at the I is equal to 0 up to r over 2 floor. So I'm going to check out of these p objects, which one of them I'm selecting exactly 2. Is that okay? Okay? So if out of these p objects I'm selecting I of them that takes 2, then what do I need to select? I need to further select r minus 2i objects. Am I correct? Does that make sense? Out of where? How many ways can I choose these r minus 2i objects? It must be out of all the remaining things, I need to pick out one of them from each. Okay, so what is the remaining? The remaining must be p plus q minus I. Is that okay? Is that okay? That's it. So this is what? This is no more difficult than the rule of sum and the rule of product. Okay, rule of sum counts how many cases are there. So maybe I'm choosing 0 pairs. I'm choosing 1 pair. I'm choosing 2 pairs. Or up to I'm choosing r over 2 pairs. Okay. Now, if I'm choosing exactly I pairs here, how many ways are there? So I'm going to choose, I have P choose I ways to choose the I pairs, and then I have P plus Q minus I ways, I choose R minus 2 I ways to choose the remaining R minus 2 I items. Is that okay? Okay? So each part here is a rule of product, and then the summation is the cases, the rule of sum. Okay? That's it. Okay, so it looks really tedious, yeah, but don't worry. If you see something like this, at least you have one more way to interpret the product of some polynomial. You can think of this as a counting problem. Okay, the coefficient is the number of ways to count a certain case, and then you make a story, and then you count it. That's it. Is that okay? Good. So I hope you like these 2 problems. These 2 problems are not exactly using generating function to solve counting problems. But on the other hand, we are using generating function to the connection between these 2 to solve some other problems. Okay? Good. Now, let me see. Okay, now, let's move on to the next topic, exponential generating function. So what is it? So first of all, let's switch the topic here a little bit. We want to count permutation. Okay? And let's see why we can't use the normal generating function to help. Okay, so if you still remember, we have, so let's say we have apples, 1 apple and 1 orange. And when we want to get the generating function of the combination of apples and orange. So for 1 apple and 1 orange, the selection problem is like we have one way of selecting no apple, and then one way of selecting an apple. Is that okay? And multiply with, we have a way of not selecting any orange, plus we have a way of selecting an orange. Is that okay? And then after that, after doing the expansion, we will have what? We will have a case of no apple, no orange, plus just apple, no orange, plus just orange, plus apple orange. Is that okay? Is that okay? And somehow we have also introduced the indicator variable x here. So let's make an x here. So let's make an x here, so that these 2 will be multiplied with x, and then these 2 will be multiplied with x squared. Is that okay? Okay. Now, so far so good, right? So far so good. When we are doing combination, so 1 apple, 1 orange, right? And then here, apple and orange together. But when we are doing permutation, so how many permutations we can make with size 2? So when we are selecting 2 objects, so we have 1 apple to select, we have 1 orange to select. How many ways can we get a permutation of 2 objects? So we can have apple and then orange, and orange and then apple. Am I correct? So counting combination is okay, but counting permutation is not okay. Just using this formula, after doing expansion, we will not be able to handle this one and this one together. Okay. So instead, we are going to invent something. Okay. So for this case, the counting combination case, the corresponding generating function is 1 plus x times 1 plus x. And then we will get 1 plus 2x plus x squared. This is combination. But for permutation, we hope to get something like 1 plus 2x plus 2x squared. Because there is one way to select nothing. We have two ways to select exactly one thing. And then we have two ways to select exactly two things. Is that okay? We hope to get something like this. But then we don't have it. So instead, we are going to define a new thing called exponential generating function. Okay? So let me define it. So, but before, so GF, the normal generating function, we usually call it the ordinary generating function, OGF. Okay, so OGF for a sequence of A0, A1, A2, we will get it into something like A0 plus A1x plus A2x squared plus A3 x cubed, and so on. Is that okay? O stands for ordinary. Now, exponential generating function is we usually call exponential generating function as EGF. Okay? And then the same, we are interested in the terms A0, A1, A2. But then in that case, we are not directly multiplying AI with x to the power I. We are doing a little bit strange things here. We will make A0 the same as A0 plus A1 divided by 1 factorial x. Is that okay? Plus A2 divided by 2 factorial x squared plus A3 divided by 3 factorial x cubed, and so on and so forth. Is that okay? Strange. But later, we will see that it is really useful when we are solving the counting problem for permutations. Is that okay? Okay, let's do some practice first. Okay. 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 Okay, so question number 1. So permutations, right? So let's do something like this. So what is the EGF for Pn0, Pn1 up to Pnn? So this is the first question. What is it? So the EGF, by our definition, it will be equal to, just plug it in, this will be equal to Pn0 plus Pn1 divided by 1 factorial times x plus Pn2 divided by 2 factorial plus x squared plus dot 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 up to Pnn divided by n factorial times x to the power n. Is that okay? Plus nothing else. There is a 0 here. So it stops. It stops. Okay? can we simplify this? So this is what? What is Pn0? How many ways are there to choose 0 objects and then do a permutation on them? You have n objects altogether, right? And then how many ways to pick 0 of them? And then 1. Very good. So there's one way. Plus, okay. And then, actually, let's take a look. So all of the terms here are strange. So plus 0, I make it here. So let's have a blackboard here for our calculation. So in fact, we are looking for Pnr divided by r factorial. This is the general term here. Am I correct? What is Pnr? What is Pnr? What is Pnr? What is Pnr divided by r factorial? What is it? Pnr, number of ways to choose r objects out of n objects. So it is n times n minus 1 times n minus 2 up to, you take r terms in total. So this is going to be n minus 1, n minus 2, r terms. And then you want to divide this by r factorial. What is it? This is very, very familiar. What is it? This is n. Yes, very good. Cn choose r. So this is actually n choose r, right? Is that okay? Good. So here, this term is equal to n choose 1 times x plus n choose 2 times x squared plus n choose n times x to the power n. Is that okay? And what is it? What is it? This is equal to? What is it? What is it? This is the binomial theorem. This is equal to 1 plus x to the power n. Is that okay? Good. Oh, that's nice. What is so nice about it? It looks like exponential generating function still has some rule of product thing. This is about permutation of n objects, right? Permutation of n objects. So this is a product of 1 plus x times 1 plus x. There are n of them. It looks like 1 plus x is about the permutation of a single object. If you forget everything else, you just have one object. There are 2 ways to choose it. To do so, one is you choose not to use the object, and the other is to use this object, right? Okay. So in that sense, 1 plus x actually, each of these terms, 1 plus x, actually 1 plus x is equal to what? 1 plus x is equal to 1 plus 1 over 1 factorial x. So this is something like exponential generating function of one item, one object. And then 1 plus x to the power n is like the exponential generating function of the n different objects multiplying together. So somehow, we are not sure yet, but somehow this may be a good thing for us. The exponential generating function about how n objects are going to permute, it turns out that it is equal to the product of the exponential generating function of each object multiplying together. Okay, so somehow this is a relationship we are going to explore soon. Okay, but let's do some practice of EGF for the moment. Okay, let's do one more exercise before we take a break. Okay, somehow this is a nice observation, and then it may be useful in general. Okay. How about this one? So this one is going to be also very useful. So we want to find out what is the EGF for 1, 1, 1, 1, the infinite number of ones. What is the EGF for this one? So easy, right? So the EGF for this one is equal to 1 plus 1 over 1 factorial x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. Is that okay? Plus, anyone can recognize this one? What is it? This is a, okay, this is going to be a Taylor's expansion of something. What is it? Very good. So this is, so what is it? So what is it? So first of all, this is, we set x, all x to be equal to 1. So this is going to be a value, right? So this is equal to e. Is that okay? And then what is it? This is equal to e to the power x. Is that okay? Okay. Good. So somehow, if you see later that something like this appears, then immediately you can simplify this as e to the power x. This will help us to simplify the calculation in a lot of cases. Okay. Okay, so how about we take a 10 minutes break and then we come back. We will really see how exponential generating function is related to counting permutations problem. Okay, thank you. Okay, so let's take a break.